Welcome back to the Workbench YouTube. I wanted to share with you today my most recent design for a titanium windshield for my camp stove. This is it here. I'll go over it in detail, but what we've got here is a piece of 0.1mm titanium foil. I've folded the edges and planished them over, and then we have a crenulated piece attached on the inside here, which keeps the shield separate from the wall of the cup and allows the hot air to move up the outside, keeping the heat close up against the pot. We have a steel spring here just to keep it tight and held on, and a couple of rivets to hold things in place. Some benefits of this design: it stays with the pot, so you don't need some kind of a device down here on the canister for it to sit on top of. Also means you can move it up and down as necessary depending on factors such as how much wind you're dealing with, and also making sure you're not getting too much reflected heat from the flame coming down back onto the gas canister and creating a potentially dangerous environment, what with the pressure and the heat and the exploding and the face burning. Don't want that. This particular one weighs approximately 16.8 grams. Don't know what that is in freedom units. Originally I played around with some of this 0.2mm titanium. You can see it's twice as thick as this is, obviously, but in the hand and in working with it, it's significantly more robust than the 0.1mm, which means that with a single piece of it, if you give it a good bend, you can get it to kind of just stick to the bottom of the pot by itself. But the downfall of this design is that it doesn't allow anywhere for the hot air to rise around the outside, which is why I put these holes in this one, but then that cuts down on the windshield effect of it and doesn't work quite as well, so I tossed that around. One of the concerns I had was that the spring here might get hot and lose its temper, but in testing I found that isn't a problem. Even if I turn the gas up to a ludicrous degree and balance the pot precariously on the edge here in a fashion that you never would, and then imperiled my fingers by pulling this down all the way to here, it just doesn't seem to get hot enough for losing its temper to be much of a problem. But hey, maybe it will in future, and if that's the case, we'll come back to the drawing board. Now titanium gets a nice glowy red, the titanium of the stove. And as far as dimensions go, I made it so that it could slide down inside the mug. My Snow Peak 600. It's the oldest piece of gear that I'm still currently using in main rotation. And my Fat Daddy-O's baking pan. So the Fat Daddy-O's fits down inside the heat exchanger fairly nicely. And then once the stove's off, that goes down the bottom and the gas bottle goes on top, and everything fits together nicely. This heat exchanger, I've got it secured in 3 locations with a rivet, not a pop rivet, a hammer over rivet. I got these in a 3mm size, and I also got a 3mm hole punch I don't know how many punches one of these would be good for on 0.1 mil titanium. My guess is that it would blunten out eventually, but it seems to do the job, and it makes a fairly decent little hole. A little bit rough on one side, but you can clean that up with a sharp knife, or possibly with a sharp drill bit if you're just very careful by hand. I tried a few different ways of, this is my test piece, a few different ways of making these heat exchanger folds. First I tried the little triangles, but I didn't quite like how that was going. You know, maybe the proper way to do this would be to make a little die tool of some sort that you could press together to create the parts. But what I ended up using was something like this pair of scissors here that has a nice flat mating surface in here. I actually used this little black handled pair, and you know, you can pinch the piece in there, get yourself a nice little fold on it that approaches 90 degrees, and then you can just kind of index it over there and make another 90-degree bend, just like that. Not quite as easy on camera. And then you can bend it back if you want, and before you know it, you've got something like a square crenulated kind of pattern going on, as long as you're kind of careful about making sure you keep making each bend go the proper way. Yeah, you can get pretty good at it. I suggest using a test piece to see what you're doing first. But that worked out quite nicely, I thought. As far as finding the correct sized spring for this, I just went down to my local hardware store and I picked up a variety pack of springs, and I managed to find one that suited my purposes out of there. Probably a good thing to have lying around for the future. And just a few hints about working with titanium foil. If you've ever cut up an aluminium can, you might be familiar with how easily the edges of that can cut you. It's the same thing with titanium. So well, you can cut it with not your good sewing scissors, but with any decent pair of scissors you can cut titanium foil. But once you do that, you have to be very careful of the edge that you've created, because it will cut you, especially these little corners. They can be quite sharp, and there are a few ways of dealing with that. If you've got some fine metal files, you can just round over the edges in that. If you have a knife that you might use for fire lighting that's got a decently sharp spine on it, like a 90-degree edge, you can use that to rough over any sharp corners. You just keep touching it up like that. Eventually you bring it down to a fairly smooth roundness. And another way you can do it is with your common garden pebble. Just obviously be careful what you're doing with your fingers when you're doing this. You don't want to miss the pebble and ending up slicing yourself down to the bone. That would be unfortunate. Yeah, it's not strictly necessary, but for structure and rigidity, I like to fold the edges over. So what I would do is measure about 3 or 4 millimeters, mark that line, and then I like to go to my kitchen bench, which has a nice sharp edge, and start by folding it over that. Or you could fold it over with a straight edge. Start by just making your little crease so that you've got something to work from. And then once that's decently started, you can, you know, carefully kind of just start folding it over with your fingers, just like that. And then to finish it off, take that over to your old workbench, and then with your hammer, you just want to come along and gently planish it. Doesn't need to be much. Just kind of give it a little tap and rub, and it'll fold the edge over nicely where you managed to do that. If you've got any suggestions for how you think this design might be improved, please let me know down in the comments. I'm sure something will occur to me at some point. And just to round out the video, I might just put back together my cook kit and talk about it piece by piece as I go. 600ml pot seems to be everything I need. This is my cozy, which I made from canvas and merino felt. It's really nice for once I bring food up to a good temperature, just let it sit in there and finish cooking. There's my Fat Daddy-O's baking pan. That's just for hybrid baking in. Standoff. I've got a video up with these little feet that I made that clip onto the canister. I quite like this Avenue Spondonicles, billy grubbers, whatever you want to call them. They work quite nicely. We've got the stove. Which stove am I using these days? Is it a fire maple, is it? Yeah, it's the fire maple. It's not a bad little stove. That just fits down in there nice and neat. Mini bit later, down we go into the bottom. Gas canister on top, upside down, lid. And there we have it, my whole cook kit. So yeah, there you have it. Hopefully someone out there likes this design, and if you do, please feel free to recreate it, modify it, do whatever you want for your own private use. Go for your life, I don't care. If I see this design for sale on a website somewhere. Anyway, enjoy hiking and camping, and I'll see you next time.